Hello, today we're going to learn a little bit more about probability, and specifically we're going to talk about theoretical probability. So, probability is the measure of how likely an event is to occur. And the set of all possible outcomes is called the sample space. These are just kind of some terms that you need to know. So like if I say that there are 10 marbles in a bag and what's the likelihood of pulling a red one, the sample space would be 10 because there's 10 total marbles. Then for equally likely outcomes, the theoretical probability of an event is the ratio of the number of favorable outcomes to the total number of outcomes. So, if there are 4 red marbles out of 10 and I want to know what the likelihood of pulling a red marble out would be, favorable outcomes is the 4 red marbles, the total number is the 10 total marbles. So it would be a 4-to-10 ratio, which would reduce, but we don't care about that right now. So speaking of marbles, a jar contains 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? So we want to know the number of red marbles over the total number of marbles. So there are 32 red marbles, and when we add 32 and 28, there are 60 total marbles, and that fraction reduces to 8 over 15. So there is an 8/15 chance that we will choose a red marble. And I think you should watch at least one in each section, but if at any point you feel like this is a waste of your time and you understand it, please go ahead and just go through. You can do them. Just make sure you check your answers and you understand how and why you got them. Okay, number 2, a letter in the word restoration is randomly selected. What is the probability of selecting a vowel? So we want to know vowels. Those would be the favorable outcomes over all the options, so all letters. I can't spell letters. This is good. So when we count in restoration, vowels are A, E, I, O, U. Okay, so that's just like a random fact you need to remember and know. So we have 1, 2, 3, 4, 5. 5 vowels out of 11 total letters. And that fraction does not reduce, so that's your answer. I decided to go through all of these because there are so many random tidbits of information that you have to know to answer these questions that I wanted to kind of refresh your memory on some things you may not ever think about. So, for example, number 3, a day in the month of January is randomly selected. What is the probability of selecting a prime number? So you have to know what a prime number is. A prime number is only divisible by 1 and itself. So we need to know also how many days are in January. There are 31 days in January. All right, so let's look. We have 1 is not a prime number. That's also a fact that you have to know. 1 is not prime. Okay. So 2 is a prime number. It's only divisible by 1 and 2. 3 is only divisible by 1 and 3. 4 is also divisible by 2, so that doesn't work. But then we have 5, 7, 11, 13, 17, 19, 23, 29, and 31. So there are 11 prime numbers out of 31 days in January. The next one, number 4, 2 dice are rolled. What is the probability that the sum of the 2 dice on the next roll is at least 9? So, first of all, we have to figure out how many. All right, so we want sum greater than or equal to 9 divided by total pairs. So we have to figure out how many total options there even are. So when you have 2 dice, the first time I want to show you how to make this little chart. In the future, you may be able to visualize it in your head. You may be able to remake it, kind of whatever you want to do. So if we roll a 1 on the first round, then we can roll a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, 1, 5, and a 1 and a 6. Okay, or we can roll a 2 the first time. So we get 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, or 2 and 6. All right, so I filled in all the rest of them. So for each number 1 through 6, you can get the other dice to be 1 through 6. And so there are 36 total different possibilities when you roll 2 dice. And anytime it doesn't specify, you assume that they are 6-sided dice. That's traditional dice. Okay, we want to know which ones add up to at least 9. So if we roll a 1 in the first one, we would have to roll an 8 the second time to get a 9. And that's not an option. If we roll a 2, we would have to roll a 7. There are no 7s. If we roll a 3, we'd have to roll at least a 6. So that's this guy. If we roll a 4, we have to get at least a 5. And anything bigger than that is greater than 9. So that's allowed. And then 5 and 4, 6 and 3, and all the ones bigger than that. So there are 10 total favorable outcomes. Okay? So 10 over 36 reduces to 5 over 18. And that's our answer for this one. Okay, here is another one. This one asks, what is the probability of drawing a heart or a club from a standard deck of cards? So a lot of you have never played cards. I learned that last year when I tried to teach probability for the first time. So the first thing I want to do is look at what is even in a deck of cards. So here is a deck of playing cards. There are 52 total cards in a deck. There are 4 suits. So each one of these represents a suit. Okay, so these are clubs, spades, hearts, and diamonds. And then these 3 cards of each suit are face cards. So there are 13 of each suit. And then there are 26 reds and 26 blacks. So this is something that for the purpose of probability and potentially the ACT, you should try to kind of become familiar with what is in a deck of cards. It's a really common thing to use in probability. All right, so the question asks, what's the probability of drawing a heart or a club from a standard deck of cards? So there are 13 hearts and there are 13 clubs. So that's 26 favorable outcomes. And there are 52 total cards. And that's going to reduce to 1/2. You could also see that that's 2 out of 4 of the total suits. And so that would also show you that it would be 1/2 of the cards. Okay. The last one in this section, there are 8 books lettered A through H on the shelf. If Scott randomly chose 2 books, what is the probability that he chose books A and B? So it doesn't matter what order he chooses these books in, and an easy way to figure out how many total ways. So think about this. If we had done on the last assignment that we were doing, how many ways can Scott randomly choose 2 books from 8 books? Well, he can choose them 8 combination 2 ways. And only one of those combinations is going to be the right one. Is going to be A and B. Because order doesn't matter in this. It doesn't say that he chose them in order. It just says that he chose them. So A and B and So when we use our calculator, we're going to find that 8C2 is equal to 28. And so there is a 1 in 28 chance that he chose books A and B. The next section discusses complements of an event. And the complement of an event is the probability of the event not happening. So since the sum of all probabilities in the sample space is 1, so let's think about that. If you have, 4 red marbles and 6 blue marbles, and you add the probability of red marbles and the probability of blue marbles, you're going to have 4 out of 10 plus 6 out of 10. Well, that's 10 out of 10, which is 1. Okay? So the sum of all probabilities in a sample space is always 1. Then the probability of an event not happening, which is represented by this, is 1 minus the probability of that event. So this little guy means complement or not E. All right, so this says the probability that it will snow tomorrow is 7 out of 20. What is the probability that it will not snow? So if 7 out of 20 chances say that it will snow, then there are 13 of those chances that say it won't. And we can see that by doing 1 minus 7 over 20. And when you can type that in your calculator, you can do whatever you need to do to get this, but that equals 13 over 20. Number 8, a month of the year is randomly selected. What is the probability of getting a month that does not begin with the letter A? So the months that begin with A are April and August. There are 12 total months, so 2 out of 12 start with A. So that means that 1 minus 2 out of 12 do not start with A. So 10 out of 12 or 5 out of 6 will not start with A. Number 9, if the spinner to the left is spun, find the probability that it lands on a number that is not prime. So remember that, so let's count all the prime numbers. So there's 1, 3, 5, 7, 11, 13, and that's it. So there are 1, 2, 3, 4, 5, 6 out of 16 that are prime numbers. So we're going to do 1 minus 6 out of 16. That leaves 10 out of 16. You can find that by doing 16 minus 6. And that reduces to 5 out of 8 chances that it will not be a prime number. Okay, 2 dice are rolled. What is the probability of not getting doubles? So we saw in number 4 that there are 36 total options when you roll 2 pairs of dice, or 1 pair of dice, 2 dice. Well, there are only 6 options where you get doubles. You can get 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, or 2 6s. So, since there are only 6 out of 36 ways to get doubles, if we do not want doubles, we just subtract that from 1. So we'll get 30 out of 36, which equals 5/6. Next, we're going to talk about compound events, and we're going to go ahead and fill in these formulas, and then we'll talk more about examples. So compound events are the probability of 2 or more simple events. So when we have independent events, so if you are an independent person, that means that what other people do does not affect you. So independent events do not affect the outcome of each other. The outcome of one event does not affect the outcome of the other. The formula for this is going to be probability of A times probability of B. Okay, this is going to make more sense as we do examples, obviously, but all right, dependent events, that means, so a dependent person relies on other people, changes with other people, you know, does the things that the people around them do. When the outcome of one event does affect the outcome of the other, that is a dependent event. And the formula is the probability of A times the probability of B after A has already happened. All right, let's dive in. Okay, so a die is singular for dice, in case you don't know. A die is rolled 3 times. What is the probability of getting ones on each roll? So if I roll the dice and then I pick it up and roll it again, what I get on the first roll is not going to change what I get on the second roll. So these are independent events. And even though they're labeled by category, I still want to specify why they are independent or dependent. So we're going to roll it 3 times. So the first time, there is a 1 out of 6 chance for getting a 1. The second time, there's a 1 out of 6 chance. And the third time, there's a 1 out of 6 chance. And we just multiply those all together to get 1 over 216. For number 12, a coin is tossed, then a day of the week is selected. What is the probability of getting tails, then a day starting with the letter T? So tossing a coin and choosing a random day of the week do not affect each other in any way. Not going to change any outcomes. So we're just going to take the probability of each event and multiply those together. So the coin is tossed. We want the probability of getting tails. That's going to be 1/2. There are 2 options. One of those is tails. Then we're going to multiply that by a day of the week is selected. There are 7 days of the week. We want the ones that start with the letter T. That would be Tuesday and Thursday. There are 2 of those. So we're going to get 2 over 14, which reduces to 1 over 7. So the likelihood of both getting tails and a weekday with a letter T is 1 in 7. Okay, so this is another independent event one. This says a bag contains 8 red crayons, 14 purple crayons, 6 yellow crayons, and 4 green crayons. A crayon is selected, replaced. Sorry, I thought I was drawing without circles, but that's okay. Replaced. Then another is selected. Find each probability. So if this is replaced, then it's not going to change. I could draw the same marble out 47 times in a row if I wanted to. Well, probably not, but you get the gist. So a crayon, I said marbles too. Anyway, doesn't matter. So a crayon is selected and replaced, then another is selected. That is what makes these independent, because the marble is replaced. So we want the probability of drawing a purple and then a yellow marble. So we're just going to find the probability of each and multiply them together. So first we want to know how many total crayons there are. And there are 32 crayons total. So we're just going to write that down for reference. So to draw a purple crayon, we would have 14 chances. So 14 out of 32. Then we put that purple one back and we draw a yellow. There are 6 yellow crayons out of 32. And I know I keep saying marbles and crayons backwards. You get the gist. The colors are what matter. When we multiply these together, we get 84 over 1,024, which reduces to 21 over 256. Okay, so these all work exactly the same. So number 14, green, then red. There are 8 greens out of 32, and there are, I'm sorry, I read that wrong. There are 4 greens out of 32 and 8 reds out of 32. So this is going to give us, actually reduced these fractions first. So I did, this turns into 1/8 times 1/4. And then we just get 1 out of 32. Sometimes it's easier to reduce them before they get really big. All right, so probability of 2 purple crayons. There are 14 purple crayons. So to draw the first one, we would have 14 out of 32 chances. Well, we put it back, so we still have 14 out of 32 chances. This reduced to 7/16 times 7/16, which equals 49 over 256. All right, now the probability of 2 yellows is going to be 6 out of 32 times 6 out of 32. This reduces to 3 out of 16 times 3 out of 16, which gives us 9 out of 256. All right, we have switched to dependent events, which is the probability of A times the probability of B after A. So we'll notice that we're using the exact same prompt, but this time they are not replaced. So if we want to draw a yellow crayon. So there are 6 yellows out of the 32 total. And then we want to draw a red crayon. Well, we drew the yellow out and didn't replace it. So now there are only 31 crayons left. And out of those 31, there are 8 red. So when we multiply these together, we are going to get 3 out of 62, and that's already reduced. I didn't write down the in-between steps, so you should end up with 3 out of 62 after you reduce. Okay, so then purple, then green. So the first one is purple, so there's 14 purples out of 32 in the bag. And then we want to do green. So again, there are only 31 left because we did not replace the purple one. And there are 4 green crayons in the bag. When we multiply this and reduce it, we get 7 out of 124. All right, number 19, the probability of 2 reds. This is where it gets a little bit different. So we draw a red first. So we are going to have 8 reds out of 32. Then we don't replace that red, so we only have 31 crayons left. And we already drew 1 red in the first one. So we only have 7 reds left. So when we multiply these together and reduce it, we get 7 out of 124. And finally, 2 greens. There are 4 greens out of the 32. But if we draw a green the first time, there will only be 3 left, and there will only be 31 total left. So when we multiply those together and reduce, we get 3 out of 248. Didn't circle this one. All right. A card is drawn from a standard deck, not replaced, and another is drawn. What is the probability of choosing a heart and then a spade? So remember back to our picture that we looked at, and you can go back to that and look at it again if you need to. There are 13 of each suit. So there are 13 hearts out of 52 cards. That's the one we chose first. And then we don't replace it, so now there are only 51 cards to choose from, but we chose a heart, not a spade, so all 13 spades are still in there. And when we multiply these together and reduce, we're going to get 13 out of 204. One more example. Jack had 4 Snicker bars and 8 Mars bars. He randomly chose a piece of candy, ate it, then chose another. What is the probability that both candy bars were Snickers? So he has 12 total bars, and he's going to eat it when he chooses it, so he's not putting it back. So the first time, if he chooses a Snickers, that's a chance of 4 out of 12. Well, now there are only 11 candy bars left, and he already ate a Snickers, so now his chances are 3 out of 11. So when we multiply these together and reduce them, we end up with 1 out of 11 chances that he will eat 2 Snickers bars. That's all. Thanks for watching, guys. Have a great day.